Any answer? You have to calculate the magnitude of the force F. Okay, fine. I got one answer as 10 Newton. We'll see. Okay, fine. Let us discuss. Pawan, unmute yourself. How are you trying to solve this?
Sir, T1 components తీసుకోండి.
Okay, you have to resolve T1 into components. Then why did you not get an answer? Where were you stuck?
Sir, almost ending లోకి వచ్చింది.
Okay, complete it. I got one answer as 1 by root 2 newtons. We'll see. Okay, Saket, tell me, how are you trying to solve this?
Sir, first we resolve T to T1, sir.
Okay, you resolve tension into components.
So
Okay. Let's call
we
it as
get a force which is perpendicular to Earth.
just a moment. Let's call the tension as T itself. Then how will you express its horizontal component? Or-
T sin theta. Sin
Okay,
45.
T sin theta, T sin 45. That is T by root 2. T sin 45. Sin 45 is 1 by root 2. So T by root 2. How much is its vertical component?
T cos root 2.
T cos 45. That is also T by root 2. See, actually tension acts along the length of the string like this. But to solve this problem, it will be easier if you take its components. Okay, good. After that, what equations did you write, Saket?
Sir, I said that F is equal to T by root 2 because
horizontal equilibrium, the force acting to the left should be equal to force acting to the right. So F is equal to T by root 2. That is correct only. And then?
Sir, we can take T as 2 no, sir, because they said that the force is applied at the midpoint of the rope. So the rope is divided into, so basically the length of T1 is 2 and length of T2 is 2.
What is T?
Tension, sir. I mean, sir, the first half of the rope will be 2 meters, sir.
Wait. What is T? Tension. What kind of a quantity is tension? Is it a length? Tension is a?
No, sorry.
What are tension, normal,
It's
force,
force,
and all?
sir.
It's a force. Okay, tension is a force. How can you equate it to length of the string? Okay. Actually, in this question, the length of the string does not even matter. Okay, I got one more answer as 10 newtons. Fine. Okay, so you can't say T is 2 anyway. That is a blunder. Aishwarya, tell me, what equation did you write after this?
So we can write T by root 2 is equal to mg. So
Vertical equilibrium, correct. See, if you observe, actually, the forces acting on the block are its weight 10 newtons and tension in this string T2 will be acting on the block. Okay, and since the block is in equilibrium, you can say T2 is 10 newtons. And the same T2 at this junction will be acting downwards. On the block, it acts upwards. At the junction, it will be acting downwards. Okay, and it balances the upward force T by root 2. So T2, which is 10 newtons, is equal to T by root 2. Fine. So T by root 2 becomes 10. That means the force F is 10 newtons. Okay, those of you who got the answer 10, good. Is this clear? Any doubts in this? Saket, did you understand?
Yes, sir.
Okay. Fine. If any of you have any doubt, you can ask, no problem. Next question. Let's say a block is suspended from a rope like this. Or, okay, I'll give you a system. These two are not stuck to each other. They are just in contact with each other. So this is the situation. Right. Mass of the upper block, let's say, is 5 kg. Mass of the lower block is 10 kg. And it is given to you that the tension in this string is, say, 15 newtons. Calculate normal force on 10 kg from the ground. Actually, in exams, this question, if they want to ask, what they can do is they can place a weighing machine below the 10 kg block. They'll tell you there is a weighing machine, and they'll ask you what is the reading of the weighing machine. That way, they'll also be testing your knowledge of whether you know what a weighing machine measures or not. Okay, can one of you quickly tell me what a weighing machine measures?
Normal force, sir.
The normal force between the object and the machine. Okay, so yeah, here I have asked you directly. Solve this, all of you. System is in equilibrium. I got one answer as 135 newtons. Okay. Fine, let us discuss. Should not take longer than this. One of you tell me. Rishi, how are you trying to solve this?
I drew the free body diagrams and then
Okay.
I'm still writing the equation, sir.
Okay. Make it fast. Send your answers, all of you. Yeah, Puneet, your answer is also correct. Okay. Rishi, quickly tell me what forces act on the 5 kg block. Pawan, your answer is correct. Huh.
Sir, the 50 Newton downwards.
Its weight of 50 Newton downwards and
then the normal force of 10 kg.
Normal force from the 10 kg block. Let's call it as N1 that will act in the upward direction. And
that's also. And the tension.
String is connected to the 5 kg block. No, so tension will also be acting on it. And tension is given to you as 15 Newton. So from this, what can you find out?
Sir, the normal force from.
You can find out the normal force from 10 kg block. Okay. And now tell me what forces act on the 10 kg block itself.
Sir, the weight of the block.
100 Newton. What else?
Then the normal from the table.
Normal from the table. Yes, that is what you are asked to calculate.
And also the normal force from the 5 kg.
5 kg will be pressing the 10 kg down. And we called it as N1. Okay. So from the first diagram, quickly tell me how much is N1?
35 Newton.
35 Newton, correct. That's all. You put that 35 Newton here, then the normal force from the table becomes 135 Newtons. That is the answer. Simple. It's a simple case of equilibrium. Wherever there is contact between objects, you consider a normal force, and wherever strings are present, you consider tension to be acting. And tension is given to you as 15. Based on that, you can tell that the normal force is 135 Newton. Okay. Now, one of you tell me, like, no need to solve, tell this directly. If we cut the string, how much will the normal force from the ground become? If the string is cut, how much will the normal from the table or the ground become?
150, sir.
150. It'll have to balance the weight of both the blocks. 150 Newton, correct. Okay. Just a moment. Suppose there is a heavy rope. Okay, the rope has mass. Let's say mass of the rope is 2 kg and a block is attached to it. Block mass you assume is 5 kg. Calculate tension in the rope at this level. What level is this? It is at a distance of 1/4 of the length of the rope from below. How much is the tension in the rope at that point? I got one answer as 70. 70 is not correct. Try. Okay, let us discuss. I got one answer as 55. We'll see. Puneet, can you tell how you're trying to solve this?
Sir, I thought that mass is total mass is 2 kg, sir. So I have just added the weight of the block and mass of the rope, sir.
But do you think that is correct?
No, sir, I'm having doubt in that approach.
Okay. See, listen, all of you. The tension at this level, basically, how do you say there is some tension here? When we learned about tension, we discussed tension is generated when an object is stretched. Okay. Now this rope, if it is cut at this point, will the upper part and the lower part separate or not? From everyday experience, you tell. Will they separate or not?
They will, sir.
They will. Means before cutting, or if the rope is not cut, the upper part is holding the lower part. Okay. So that is how you say that there is tension here. Okay. So basically, what is tension there doing? Tension at that point is balancing the weight of whatever is below that point. The system is in equilibrium, no? So whatever part of the system is there below that level, its weight is supported by tension there. Okay, so see, tension and normal force are basically supporting forces. So if you ever have to calculate the magnitudes of tension and normal, you first have to think of what they are supporting or what they are balancing. Okay, so here tension at that level is balancing the weight of the part which is below it. Okay, below that level, this 5 kg block is there, okay, and some part of the rope is there, not the entire rope. Can any of you tell me what the mass of this part of the rope will be? The total mass of the rope is 2 kg. This part's length is 1/4 of the total length. So how much will the mass of that part be?
0.5 kg, sir.
Half kg, 1/4 of the total mass. Total length L has a mass of 2 kg. Then a length of L by 4 will have a mass of 2 by 4. That is 0.5 kg. That's all. So the tension at that level is balancing the weight of 5 plus 0.5, that is 5.5 kg. Weight of 5.5 kg is 55 newtons. So the tension there is 55 newtons. Okay. One of you quickly tell me, how much will the tension at the topmost point of the rope be?
$70 newtons, sir.
Okay. At the topmost point, the tension is supporting all the weight below it. The entire rope's weight has to be supported and the block also has to be supported. So all 7 kg weight should be supported. So the tension there will be 70 newtons. So from point to point, the tension varies. And we had discussed this before also. A rope which has mass can have different tensions at different points. A massless rope will have the same tension everywhere. Okay. But a rope which has mass can have different tension at different points. Hope this is clear to all of you. Any doubts in this? Okay. Next question. Just a moment. Okay, let's consider a basic Atwood machine. Atwood machine is a simple pulley string system. Ideal pulley, ideal string. Assume two masses are connected, M1 and M2. Now, depending on which mass is heavier, you can tell to which side the system is going to accelerate. Okay. Let's assume M2 is more than M1. And it is found that the blocks accelerate at a rate of, let's say, g by 3, where g is acceleration due to gravity. Okay. If the blocks accelerate at this rate, calculate the ratio of their masses. Pulley is ideal, string is ideal. Okay. Try. Okay, I got one answer as 2:1. We'll see. Right. Pawan, how are you trying to solve this?
సార్ అంటే T1 minus M1 చేయాలా ఈక్వల్స్ M1
T1? Okay.
minus
Okay.
M1G ఈక్వల్స్ M.
Fine. Let's assume M2 accelerates downwards and M1 accelerates upwards. Will their accelerations be equal or not in this system?
Yes, sir.
They will be equal. That's the constraint here. Accelerations will be equal. On M1, there will be a tension acting and its weight will be acting M1G. And on M2, its weight will be acting M2G. And there is tension upward. Tell me the equations that you wrote. For M1, what equation can you write?
T1 minus M1G equals to MA.
Why do you want to call it T1? Just call it T, no? It's the same string on both sides, so same tension. I said string is ideal, so massless. T minus M1G is equal to M1A. Okay, and then for M2?
M2G minus T is equals to M2A.
Is equal to M2A. Okay, how can you get the ratio M1 by M2 from these two equations?
సార్ అంటే రెండు సైడ్ T ఈక్వల్ చేసుకుని దాన్ని డివైడ్ చేసుకుందాం.
Okay, you want to write from the first equation, you can take T, send M1G that side, it becomes M1 into G plus A. And in the second equation, send T that side and M2A this side, it becomes M2 into G minus A. And then you divide them, you will get the ratio M1 by M2, correct? So 1 is equal to M1 by M2 into G plus A. Acceleration is given as G by 3. G plus G by 3 becomes 4G by 3 divided by G minus A. G minus G by 3 becomes 2G by 3. You have to be quick in the calculations. So this will become 2, 1. So M1 by M2 into 2 by 1 is equal to 1. That means M2 by M1 is 2:1. Correct. Okay. See, the only thing we can do in this case is write Newton's second law. What else can we do? So proceed that way and think of how the ratio can be derived. You could have done like this also. You could have taken tension from the first equation and substituted it in the second equation. And then take all M1 terms on one side, M2 terms on one side, divide them, you'll get the ratio M1 by M2. Could have done that also. Okay, hope this is clear to all of you. Now, this same system, let us discuss one idea which will help you in solving problems. See, you all know what forces act and all. Tell me how much is the acceleration of this system. Okay, it's not related to the previous question. Think of it as a new question. Assume M2 is greater than M1. Derive the acceleration of the blocks. Any answer? Why is this taking so long? Or maybe it's difficult to type. Any answer?
G into M2 minus M1 by M1 plus M2.
Okay. So simple equations. M2G minus T is M2A and T minus M1G is M1A. Just add the equations, T will get cancelled. Left hand side you will be getting M2 minus M1 into G is equal to right hand side you will be getting M2 plus M1 into A. That's all. So the acceleration becomes G into M2 minus M1 by M2 plus M1. Okay, this is the usual way to solve. Fine. Now there is a quick way to get this answer. Listen. M2G, the weight of block M2, is trying to make the system go this way. Whereas M1G, the weight of block M1, is trying to make the system go this way. They are trying to do opposite things, exact opposite things. Okay. So on one side there is M2G pulling, on the other side there is M1G pulling, and you know M2G is the dominant force. M2 is more than M1 given in the problem. So the net pull on this system, okay, you can say, see, this is not a proper approach, but this will work. Okay, so net pull on this system, you can take it as, see, M2G is acting in one direction, or it is trying to make the system move in one direction. Okay, that is the correct way to say it. M1G is trying to make the system move in the exact opposite direction. So they are trying to do the exact opposite things. So the net pulling force can be taken as M2G minus M1G. Fine. And this has to accelerate both the blocks. Okay. So you can write this as M2 plus M1 total mass into A. Okay. From there also you can get acceleration is M2 minus M1 into G by M2 plus M1. So basically one force is trying to move the system in one direction. The other force is trying to move the system, accelerate the system in the exact opposite direction. So these two are like opposite forces. For the motion of, as far as the motion of the system is concerned, these two are like opposite forces. So you can take net force, stronger force minus weaker force, equal to total mass into acceleration. Okay, let us use this idea in another problem. Consider a wedge like this, or an inclined plane. It's fixed and smooth. One block on this side, one block on that side. The question is to calculate acceleration. Let's take this mass as m1, this angle as alpha. Strings and pulleys are ideal. Other side mass is m2, angle is beta. Calculate acceleration of the blocks. And assume the system is accelerating this way. Assume m2 is accelerating downward. You can unmute and tell the answer as soon as you solve. Okay, no need to type.
Sir, M2 cos beta minus M1 sin alpha by M1 plus M2.
For m2 you said cos beta, for m1 you said sin alpha. We'll see.
Yes, sir.
Okay. Let's just recollect the idea that we just discussed. Okay. You have to think of what forces make the system move, or what forces try to make the system move. And in this case, in this Atwood machine case, The two forces trying to make the system move are M2G and M1G, but they are trying to accelerate the blocks in exact opposite directions. So we wrote something like the net accelerating force as M2G minus M1G because they are trying to do the exact opposite things. Okay, and we equated that net accelerating force to mass into acceleration. Try to do the same here also. Puneet, your answer is not correct. Don't be in a hurry. Okay, check once.
So is M2 sin beta minus M1 sin alpha by M1 plus M2 correct, sir?
Okay, okay.
Both cases sin theta is acting,
Both
sir.
sides it will be sine itself. Okay, listen all of you. The blocks are on inclined surfaces. On inclined surface, we know we have to resolve weight. I mean, to solve problems easily, it will be better if you resolve weight into components along the incline and perpendicular to the incline. Generally, component of weight along the incline is mg sine theta, where theta is the angle made by the incline with the horizontal. So on this side, the component of weight will be m2g sine beta, because this side the incline makes an angle beta with the horizontal. On the other side, the incline makes an angle alpha with the horizontal. So that side, the weight component will be m1g sine alpha. These are the forces that can make this system accelerate. Normal forces, the other component of weight, that won't make the system accelerate. Okay. Now m2g sine beta is trying to make the system accelerate this way. m1g sine beta is trying to make the system accelerate the other way. So they are trying to do the exact opposite things. So we can use that idea here. Net accelerating force, okay, will be m2g sine beta minus m1g sine alpha, since they are trying to do the exact opposite things. And the resultant of these two, or the combined effect of these two, has to accelerate both the blocks. So m1 plus m2 into a. That's all, you'll get a. You can solve this using the usual method also if you want. Tension acts like this. Here also tension will be acting. Then you will write one equation F net equal to ma for this block. You will write one equation F net equal to ma for this block and solve. You will still get the same answer. Okay. So those of you who were not able to answer, I want you to try doing it both ways and check whether you are getting the answer or not. Then you will be able to remember this procedure better. Okay. Next. Can one of you quickly tell me what is angle of repose? Angle of repose.
Sir, it's like the minimum angle in which it needs for like the block to slide.
The minimum angle of incline at which the block starts sliding on it. Okay. You can also define it the other way. You can say it's the maximum angle up to which the block does not slide. Both things mean the same. Just a moment. Okay. Consider two inclined planes with blocks placed on them. Assume the angle is equal. The first one is rough, second one is smooth. For the rough one, assume angle is more than angle of repose. What is the formula for angle of repose? Like, how do you find out that minimum angle at which the block starts sliding?
Tan theta equal to mu, sir.
Tan theta equal to mu. So if tan theta is greater than coefficient of static friction, the block cannot stay in equilibrium. It will have to slide down. We had discussed this. So assume tan theta is greater than mu s. Okay, so the block cannot be in equilibrium. On smooth surface, it can anyway not be in equilibrium. So take the coefficient of friction as mu itself. Static friction coefficient, kinetic friction coefficient, both of them you assume are the same. That coefficient is mu on this rough surface. Okay. Assume the length of the incline is L, and in both cases, the block is released from rest. Calculate the ratio of time taken to reach the bottom of the incline. Any answer, anyone? Okay.
Sir, root 1
Huh.
minus mu cot theta.
Everything under root.
Yes, sir.
1 minus mu cot theta. Is this what you said?
Yes, sir.
We'll see. Okay. One of you tell me basically, what do you need to know, or how are you going to calculate the time taken by an object to go from one point to another? Starting from rest that is given to you, what else do you need to know to find out the time?
Sir, distance and acceleration.
Okay, initial velocity is known, distance is also known. What else you need to know is acceleration of the object. If acceleration happens to be constant, you can use equations of kinematics. Tell me which equation of kinematics can be used to calculate time?
S is equals ut plus half a t square.
That's the one which relates initial velocity, acceleration, displacement, and time. So S is equal to ut plus half at square must be used if acceleration is constant. If it's variable, it's a different story. We'll see. So the first thing you need to do in this problem is to find out the acceleration of the blocks in both the cases. How to find out acceleration? See, this is the way to think. You are asked to calculate ratio of times taken. No? So you'll have to find out the times. T1, T2. Okay. What does time depend on, or how to calculate time taken by an object to go from one place to another? We got the idea that equations of kinematics should be used if acceleration is constant. So, okay, yeah, we actually got the idea that acceleration is required. So the next step would be to think how to derive acceleration of an object. Now, in a given situation, how will you derive acceleration of an object? Assume mass is m, mass gets cancelled anyway, you won't need the mass. You will get acceleration by using Newton's second law. You have to visualize the forces acting on the object. Okay, so acceleration can be derived from net force divided by mass. So now you have to see what is the net force acting on each object. So you have to visualize the forces acting on the objects. Tell me, let's call them as cases 1 and 2. Case 1, what forces act on the block? Rishi, tell me the forces acting on the block in first case.
Sir, mg sin theta,
Which way?
like down the incline, down the incline.
Down the incline, correct. Mg sin theta, continue.
Then mg cos theta,
Mg cos theta perpendicular to the incline. Okay.
and the normal force.
Normal force from the incline. Okay. How much will the normal force be? Will it balance mg cos theta or not? Okay.
Yes, sir, it will.
It will balance mg cos theta. And
that's also.
no, it's a rough surface, friction will act.
Oh, yeah.
And
Yes,
friction will act up the incline like this because the block is sliding down the incline. Okay, these are the forces acting on the block in the first case. Second case. Puneet, tell me what forces act on the block in the second case.
Oh, mg sin theta, sir, down the inclined plane.
Mg sin theta down the incline and
Mg cos theta on the block, sir. I mean, on the inclined plane.
okay, perpendicular to the inclined plane, mg cos theta.
Yes, sir.
And
balancing that normal force, sir.
Normal force will balance it. Okay. Second case, the surface is smooth, so no friction. Okay.
Yes, sir.
So, yeah, one of you tell me, how much is the net force in the first case now? Because we need acceleration. Acceleration we'll get from net force only. How much is the net force in the first case?
Mg sin theta minus friction equal to ma, sir.
Okay. First case, block is going to accelerate downwards. Mg sin theta minus F is equal to ma. What kind of friction will act on this block as it slides down the incline? Static or kinetic?
Kinetic friction, sir.
Kinetic friction. Okay. Pawan, what is the formula for kinetic friction? Okay. Vanilla, what is the formula for kinetic friction?
Mu into normal force, sir.
Mu into normal force, which is mg cos theta in this case. So mu mg cos theta, that is the friction acting on the block, is equal to mass into acceleration of the block. Let's call it as A1. And that is why I said mass gets cancelled, mass is not needed. So acceleration of the block in the first case is g sine theta. This comes from gravity minus mu g cos theta. This is due to friction. So that's the net acceleration of the block in the first case. Second case, it's obvious. The net force is mg sine theta. So the acceleration becomes g sine theta. So second case acceleration is g sine theta simply. Okay, we got the accelerations. Now we can calculate time. S is equal to ut plus half at square. In both cases, the initial velocity is 0. So displacement will simply be half at square. Okay, so for the first block, you can write L is equal to half this whole acceleration. I'll take g common. You'll be left with sine theta minus mu cos theta. So that's half a t1 square. And in the second case, the same length L, okay, displacement is the same. And the acceleration is only g sine theta. Let the time taken be t2, square it. Divide these two equations, you will get the ratio t2 by t2 by t1. L gets cancelled, half g gets cancelled. So 1 is equal to sine theta minus mu cos theta divided by sine theta. You can write it as 1 minus mu, cos by sine is cot theta into t1 square by t2 square. And from there, you'll get the ratio t1 by t2 or t2 by t1 as required. Okay. Next question, just a moment. Slightly difficult question, but if you apply the correct ideas, you'll be able to get the answer. Few days back, we had solved one question like this. Just a moment. Suppose there is a block on a movable wedge. Okay, the wedge is not fixed this time. Angle of inclination is theta. Now, if you hold the wedge in place, the block will slide down. Due to mg sin theta, it will slide down, and you know that. But if the wedge is accelerated forward, we can prevent the sliding of the block. We had discussed this case when we discussed about pseudo force. Can one of you tell me how much should the acceleration of the wedge be such that the block does not slide? How much should the acceleration of the wedge be such that the block does not slide? If you don't
Should
remember,
it be
solve it.
more? Should it be more than the acceleration of the block?
See, it's a direct question. You have to give a proper answer. Not more than, less than. There's an exact value. Okay, if you don't remember, solve. Just a moment. Derive the acceleration of the wedge such that the block does not slide. You can assume block's mass is m if you want. Do this, all of you. See, these are questions that we solved and you need to practice them. Okay, Rishi, the answer you gave is correct only. Can any of you quickly tell how to solve this? How much is the acceleration of the wedge such that the block does not slide is the question.
So you draw the free body diagram first, then
Hmm.
calculate all the forces acting on the body, and then we make the equation, which
Okay.
will put to be
Okay.
sure, then I'll do it.
Fine. See, this block should not slide on the incline. It should not slide on the wedge. So basically, how this system is going to move is, with respect to ground, if you see, the wedge and the block will have to move forward together. That is the only case where the block does not slide on the wedge. So they must move together like this. So with respect to ground, this is what it looks like. Okay. So whatever acceleration the wedge has, the block also should get the same acceleration somehow. And who can give it that acceleration? Normal force. Normal force will have a component to the right. It can make the block accelerate at the same rate as the wedge. But for that, you have to generate sufficient amount of normal force. Okay, you'll have to write an equation based on that. Now, that is if you observe with respect to ground. Wedge will be moving. We don't want the block to slide on the wedge. So block has to move along with the wedge. Now, if you make the wedge the reference, if you observe the situation with respect to wedge, you don't want the block to slide on it. That means the block will be at rest with respect to wedge. It will be in equilibrium with respect to wedge. But the wedge is actually accelerating. One of you quickly tell me, if the frame of reference is accelerating, what should we apply? What is that kind of a frame of reference called? And what should we apply in such a frame? What are accelerated reference frames called?
Non-inertial reference frames.
Non-inertial frame of reference. And when you analyze a situation from that kind of a frame of reference, what should you consider? What extra thing should you consider?
Pseudo force.
Pseudo force, correct. So with respect to wedge, when you observe, the block's weight will be acting. So there will be mg sin theta, mg cos theta. There will be a normal force acting on it. We'll see how much that is, but there will be a normal force acting on it. Along with all these, you need to consider an additional force called the pseudo force because you are observing from a non-inertial frame of reference. One of you tell me, what is the magnitude and direction of pseudo force? Formula for pseudo force.
The mass of object into the acceleration from the non-inertial frame.
Acceleration of the non-inertial frame. Okay. Now the object on which we are applying pseudo force is the box. Mass of the box is small m. The frame from which we are observing is the wedge. Okay, we are writing the forces with respect to wedge. So you'll have to consider a pseudo force. You know, pseudo force acts opposite to the acceleration of the frame. With respect to ground, the wedge was accelerating forward. So when you observe with respect to wedge, pseudo force will be acting backward. And its magnitude will be mass of the block, which is m, multiplied with acceleration of the frame, which is what we need to calculate. Okay. And under the influence of these forces, with respect to wedge, the box has to be in equilibrium. Okay, you can resolve pseudo force into components. The angle of inclination is theta. So pseudo force, this component becomes ma cos theta. And the other component which will add to mg cos theta, that component will be ma sin theta. So you can write ma cos theta balances mg sin theta. That's all. You get acceleration as g tan theta. And you can also find out the normal force if you want. Normal force now is supporting both ma sin theta plus mg cos theta. Ma sin theta plus mg cos theta. If you generate that much normal force, the block will not slide down the incline. It will stay there itself. So to prevent sliding of the block, the necessary acceleration of the incline is g tan theta. If the wedge or the incline doesn't accelerate at that rate, okay, suppose the wedge doesn't accelerate at all, fixed, then you know the block is going to go down, and it goes down at a rate of g sin theta. Suppose the wedge accelerates forward, but not at a rate of g tan theta. Let's say it has a lesser acceleration, okay, small acceleration. Then the block will slide down, but not at a rate g sin theta. It will slide down with a smaller acceleration. Okay. Now, as this acceleration increases, as the acceleration of the wedge increases, the acceleration of the block down the incline decreases. And when the acceleration of the wedge exactly becomes g tan theta, acceleration of the block down the incline becomes 0. It won't slide down. Now you all tell me, based on your own logic, if the acceleration of the wedge is more than g tan theta, then what will happen to the block? The wedge is accelerated forward too fast. What happens to the block? I got one answer as the block moves backward. You should say the block moves, accelerates up the incline. See, if the wedge wedge means incline. If the incline accelerates at a slow rate, the block slides down. If the incline accelerates at a particular rate of g tan theta, the block does not slide at all. It doesn't go down the incline, it doesn't go up the incline. If the wedge accelerates at a rate more than g tan theta, you will see the block sliding up the wedge. That is also possible. Basically, what happens if the wedge's acceleration is too much, pseudo force becomes too much. Okay. And if pseudo force is too much, this component will dominate mg sin theta and the block will slide up the incline. Okay. So if acceleration is less than g tan theta, block will go down. If acceleration is equal to g tan theta, the block will stay at that level. If acceleration is more than g tan theta, the block will rise up also. All these possibilities are there. Okay. Now all this will happen when there is no friction to prevent sliding of the block. If there is friction, then some extra cases will arise. Basically, what happens if there is friction? Friction tries to prevent sliding. That is the job of friction. Okay, it may not completely stop sliding, but it will try its best to prevent sliding. So in the presence of friction, okay, if you consider a rough surface, consider this as the rough incline. And assume tan theta is greater than mu. Tan theta greater than mu means the angle is more than the angle of repose. The block cannot stay there on its own. It will have to slide. But if you now accelerate the wedge, okay, let's say you accelerate it at a rate of g tan theta. On a smooth incline itself, if the wedge acceleration is g tan theta, the block does not slide. If it does not slide on a smooth incline, on rough incline also it won't slide if acceleration is g tan theta. So if acceleration is g tan theta, no tendency of sliding or no tendency to slide. That means there is no need for friction to act. Even if it's a rough surface, friction will not act if the acceleration is g tan theta, because the block has no tendency to slide up or down. Okay. Suppose the acceleration is less than g tan theta. If acceleration is less than g tan theta, block has a tendency to slide down the incline. But if it's a rough incline, friction may support it and prevent sliding. Okay, possibility is there. If acceleration of the wedge, okay, let me tell you all the cases. If acceleration of the wedge is g tan theta, there's no need for friction to act at all. Block on its own won't slide. It won't have a tendency to slide. Assume acceleration of the wedge is 0. If acceleration of wedge is 0, block will definitely slide because friction is not sufficient. The angle of incline is too much. It will definitely slide. Friction won't be enough to prevent sliding. But for some value of acceleration between these two, for some minimum acceleration, friction will exactly be enough. Friction will just be sufficient to prevent sliding of the block. Are you all able to visualize this or not?
Sure, so there'll be a specific acceleration where it like slowly won't slide down at all.
There is a specific minimum acceleration at which the block does not slide down the incline.
What if it's more or less than that?
We'll come to that. See, okay. Think of it like this, all of you. Suppose you know static friction is a self-adjusting force. It can increase itself from 0 to a maximum of mu s into n. Okay, so friction can go from 0 to limiting value. Okay. First case I'll take in orange. If acceleration is g tan theta, okay, acceleration is acceleration of the wedge. That's what we are talking about. If acceleration is g tan theta, in that case, friction is 0. There's no need for friction to act. Okay. Next case, slightly reduce the acceleration. Now, if the acceleration is less than g tan theta, on a smooth surface, the block will have a tendency to go down. So if acceleration is just a little bit less than g tan theta, the block only requires a little bit of support to stay there, and friction can provide a little bit of support. Okay. So if acceleration is slightly less than g tan theta, friction becomes non-zero and prevents sliding. Okay, decrease the acceleration further. Acceleration is significantly less than g tan theta. Then what will happen? The block will have a greater tendency to slide down. Then in that case, you will need more friction. And friction can increase itself up to a certain extent. It can increase itself up to limiting value. Okay. So that is what I'm talking about. As you reduce the acceleration of the wedge, the dependency on friction keeps increasing. And for a certain minimum acceleration of the wedge, maximum full friction will be acting. And if the acceleration of the wedge goes below that, friction won't be enough to prevent sliding. The block will have to slide. Okay. Is this clear to all of you? Are you able to visualize what happens? Pawan, did you understand?
Yes.
Okay. Aishwarya, is this clear?
Yes, sir.
So now the question is to find out the minimum acceleration of the wedge for which the block will not slide down. It's a rough wedge. Okay. So in exam, they will ask you that question directly. All this background thinking you'll have to do on your own. Okay. That is what makes physics questions tough. Why there should be a minimum? What happens if there is no friction? All those things you'll have to think on your own. Okay. That's why solving physics questions takes time. And you make one mistake anywhere, the entire solution will go wrong. it requires patience basically. You have to think carefully and solve. It's not like you apply the formula, you get the answer, or you know the concept, you get the answer. Not enough. Okay. So let's say friction coefficient mu is given to you and mu value is less than tan theta. So if the wedge does not accelerate, the block cannot stay there. It will slide off. Friction won't be enough. So some minimum acceleration should be there for the wedge such that the block does not slide down. That is what you have to calculate. Angle theta is given to you. Friction coefficient is given to you. What is the minimum acceleration such that the block does not slide down the wedge? Try this, all of you. I'll give you 5 minutes to solve. If you have any doubts, you can ask. Any answer? You are looking for the minimum acceleration for which the block does not slide down the incline. Okay, fine. Can one of you tell me the forces acting on the block? Forces acting on the block.
Sir, mg sin theta.
Weight components, mg sin theta, mg cos theta will be acting. What else? What other forces act on the block?
There is friction there, or is it a smooth?
What are you saying? The entire question is about the block being on a rough surface, no? If it's smooth, there's only one acceleration such that the block does not slide. Okay, friction is there. Okay, one of you tell me quickly, what all forces act on this block? Or if you have any answer, you can tell.
Your acceleration equal to g into sin theta minus mu cos theta by mu sin theta plus cos theta.
Okay, I think this is correct. We'll see. Vanilla, how did you solve?
So like I took pseudo force and balanced all
Okay,
the
you
forces.
you considered the situation with respect to the wedge. Okay, good. See, we don't want the block to slide. Okay, that means with respect to wedge, it should be in equilibrium. So let's consider the situation with respect to the wedge itself. The block can be prevented from sliding only if the wedge accelerates. That is compulsory because mu is less than tan theta. Without the wedge accelerating, the block cannot be at rest. Okay, it will slide down. Friction is not sufficient. So assume the wedge acceleration is A. If the wedge acceleration is A, when you are observing with respect to wedge, you need to consider a pseudo force in a direction opposite to the wedge, MA. Along with that, the usual forces will be acting. Mg cos theta, down the incline mg sin theta, perpendicular to the incline upward normal force. And you are looking for the minimum acceleration such that the block does not slide. Then in that case, maximum friction will be acting up the incline like this. You have to take help from friction. Otherwise, if there's no friction, there's only one acceleration which can prevent the block from sliding, that is g tan theta. With friction, you can afford to reduce the acceleration a little bit. That is what we are finding out now. So these are the forces acting on the block. And under the influence of these forces, the block must be in equilibrium. Now write the equilibrium condition. You have to take components perpendicular to the incline, balance them. And in another equation, you will take components parallel to the incline and balance them. Okay. Perpendicular to incline, what forces will be acting? Let us resolve pseudo force into components. One component of pseudo force, MA sin theta, will act this way. Another component of pseudo force, MA cos theta, will act this way. So perpendicular to the incline, perpendicular outward is normal. Perpendicular inward is mg cos theta plus pseudo force component ma sin theta. So this is the normal force on the block. Okay. Next, parallel to the incline or wedge, whatever it is. The block is not sliding, so equilibrium condition, you will write friction plus ma cos theta. These two are acting up the incline. They should balance the force acting down the incline, that is mg sin theta. That means friction is equal to mg sin theta minus ma cos theta. And we know that we are looking at the extreme case where the block is just about to slide, but it's not sliding. Means the friction acting here is the limiting friction. In that case, we can replace F with mu n. Okay. Therefore, mu into how much is the normal force? Mg cos theta plus ma sin theta is equal to right side mg sin theta minus ma cos theta. Okay, that's why I said this is a slightly difficult situation. Mass gets cancelled. Now you keep the A terms on one side, G terms on one side. I think the answer that Vanilla has given is correct. Okay. So if you keep only the G terms on one side, G sin theta will be there. And from this side, you get mu G cos theta to the other side. So G sin theta minus mu G cos theta divided by A terms on one side. If you keep mu sin theta plus cos theta. Okay. Yeah, this is correct. So that is the minimum acceleration that the wedge should move with, such that the block does not slide down the incline. Hope the solution is clear. Ask me if you have any doubts. And Vanilla, had you solved this question before itself, or you solved it now? See, it's possible that you had solved this
Now
question
only
before.
I solved.
Okay, good, very good. And I really appreciate what Vanilla is doing. She sends the solutions to almost every worksheet. Last like 2-3 worksheets she has not done, but almost every other worksheet she is doing and sending me the solutions. I am not telling you corrections. There are some corrections in the last worksheet answers that you sent. I'll send you the corrections, but I expect this from all of you. Okay. Take some time. Like that is the intention in taking classes on alternate days. No, one day you'll attend class, next day you have to solve the worksheet. Okay, if that day worksheet is not there, previous worksheet you solve. Okay. Practice is very important. You need to apply what is discussed in the class, and you need to extend your thinking a little bit also. In worksheet, some new situations also will be given. Okay, and those situations will be related to what are discussed in class. Okay, so just to see if you can apply a little bit of extra, apply a little extra knowledge, extra ideas to solve a new situation. Okay, and all the hints are given in the worksheet. If you do those, it will be very beneficial. Okay. If you are not able to do on alternate days, at least sit on weekend and do the worksheets sent that week. Okay, and send them back to me so that I can check how well you are understanding and all. Okay, so we'll stop it here for today. It's been too long. So what all did we discuss? We just solved problems based on laws of motion. We revise some of the ideas in this chapter and then discuss questions. Next class, which will be on Friday also, we'll be solving problems based on laws of motion. Make sure you revise all the ideas. Okay, revise the notes or all the ideas that we had discussed so far. Okay, thank you all. We'll continue on Friday.